Okay, so we'll start. A very good morning and warm welcome to everyone. AES is celebrating Azadi Ka Amrit Mahotsav, an initiative of Government of India to celebrate and commemorate 75 years of progressive India and its glorious history. Under the Azadi Ka Amrit Mahotsav celebration, presently AES is organizing various activities for staff members and students to celebrate Swachhata Pakhwara. Under this event, today, we have called Dr. Poulomi Mukherjee for a lecture on biocomposting. Before starting of the lecture, may I introduce Poulomi Mukherjee. Dr. Poulomi Mukherjee has been working in nuclear agriculture and biotechnology division of BARC for last 17 years. After successful completion of orientation course in engineering and science organized by Bhabha Atomic Research Center. She has obtained PhD in life sciences through Homi Bhabha National Institute and made several verbal presentations in national and international conferences. She has 13 publications in international journals to her credit. She has developed 2 technologies, one in nanomaterial and other in microbial biocomposting, which are published in BARC website. The biocomposting technology developed by her has been successfully transferred to 35 companies. Today, we are privileged that she is present here to share her views and to share with us her idea about the topic. So please welcome Dr. Poulomi Mukherjee. Without wasting any time, I'll just hand over the mic to Dr. Poulomi Mukherjee. Madam, you can start the proceedings. Thank you, madam.
Thank you very much for the kind introduction, Mr. Sanjeev. I consider myself lucky to be a part of the Azadi Ka Amrit Mahotsav and the Swachhata Pakhwara being organized by Atomic Energy Education Society. I thank them for inviting me to share our work with a very, very wide base of students, parents, teachers. So thanks a lot from Nuclear Agriculture and Biotechnology Division of BARC. So while we go live with the presentation, the topic is regarding biocomposting. So actually, nature has been doing it silently for us for centuries and for thousands of years, and that is why we are having such a beautiful earth to live in. However, after the Industrial Revolution, we have interfered a lot with natural processes, and hence we are facing all the problems that okay. So we are facing several problems, and to address some of them, we keep developing solutions at BARC, and one such solution is the rapid biocomposting technology, which is jointly developed by Dr. Darshana Saliskar and myself under the able guidance of Dr. Poulomi Mukherjee. So what you see is our beautiful earth, and this beautiful earth is actually the only home we have. So till we explore and find out another planet, this is indeed our only home. And not only is it our only home, but it is also our only provider of air that we breathe in, provider of water that we drink, and provider of the food that we eat. So everything that we need for sustenance of life is coming from this planet. But through our actions, through our activities of economic progress, and through our desire to get a more and more comfortable life, what are we giving back to the earth? So through the water cycle, Mother Earth gives us beautiful rain, but we in turn give it back acid rain. Similarly, you see the soil, the topsoil of Mother Earth gives us food, but we give back garbage, which is dumped very close to our colony in the Devna dumping yard. Piles and piles of garbage, several stories high, is being dumped. And that happens through all the important urban centers of the world. It gives us a beautiful weather to enjoy, but we give her what is known as global warming. So the trees, they give us oxygen to breathe. We pollute the environment and give carbon dioxide back. And this story continues. So much of marshland is being reclaimed to make industries, to make houses to live for human beings. So in the process, what would have actually been a very rich diversity hotspot is being murdered and made into concrete jungles. So this is what we are giving back to Earth. And in the process, we are threatening the human civilization. So what are the current threats that we see? So one is indeed global warming, biggest threat perhaps. And through the various effects that global warming is having on nature, is having on agriculture, food crisis, agricultural crisis is a very, very important threat. And it has the potential to wipe out human civilization. The others are like arms race mediated by nanotechnology, bioengineered microorganisms, and nuclear war. So these are the 6 or the 5 most important threats which human civilization is facing. And if we want a continuum of the civilization, that is generations after us, they should have a comfortable life that we are currently having. It is our responsibility to take care of these threats. So what can we do to reverse? We have done something. Now, what can we do to undo what we have done? It is our responsibility. Since we have done so, it is indeed our sacred responsibility to take care of it. So is it possible that we can remove what we have sent to the atmosphere and we can store it in such a form that it is locked up, that it in 1,000 years, maybe it is not sent back at the same rate to the atmosphere as we have done it? Is it possible? So here comes in the global carbon cycle. What happens is atmospheric carbon dioxide is taken up by plants through photosynthesis, and then through various processes, they reach the soil. Now we can enhance this process by adding carbon amendments to the soil. And in this form, we can actually captured carbon dioxide from the atmosphere, we can prevent it from going back again. So one of the ways is by adding compost to the soil. So what we are doing in effect, we are not capturing, the plants are doing this job very generously for us, capturing carbon dioxide through photosynthesis, converting it to their biomass, and whatever is useful in the form of food for us, we can take it. The rest, it is our sacred responsibility that we first process the rest in a manner which is very, very close to nature, in a manner nature does it, and then we send it back to soil. Now, why should we send it back to soil? Because it is from the soil that plants have taken in various inputs for its growth. It is from the nature, from atmosphere, that it has captured carbon dioxide. Now, if this can be captured into the soil, can be captured from the atmosphere and deposited into the soil, this is one easy as well as sure short way of locking the extra carbon dioxide that is currently in circulation in the soil, and then preventing it from going back at the fast rate which has been happening in the previous century. So now we'll see how nature recycles. So it's like, this is the tree that has grown, and it is a big tree. Now, when senescence comes, that is, the leaves start yellowing. After that, it falls off from the branches. And then various organisms which are known as detritivores, that is, they eat detritus or decaying organic matter, dead organic matter. So detritivores like, say, insects, like millipedes, centipedes, earthworms, they feed on this organic matter, and they also break it down into smaller and smaller particles. Now, these smaller particles are now taken up by microorganisms, bacteria, fungi, actinomycetes, and they use it as their food. After they have used it as their food, whatever remains is again sent back to the soil. And in the process of utilizing this as their food, they also unlock many, many nutrients which are again available to the soil, and fresh growth of plants and trees can take place. So this is how nature is continuously recycling whatever is dead, and from the dead, actually new life is coming up on this planet. Another very important part of the organic processing is humus. So humus is such a substance which is the source of organic carbon in the soil, and this undergoes very, very slow degradation once it is formed. So it takes hundreds of years to again form carbon dioxide from the humus. So this is one of the important ways that we can store the circulating carbon dioxide from the atmosphere to this in the soil. So converting it to humus. So we have seen how waste is handled by nature. Now let us revise how we look at waste. We means how human beings look at waste. So what is waste to us? It is a refuse. It is of no economic importance. Mostly it is of no economic importance to us, because we have already taken in what was important and we have left which is not of use to us. So that is what is waste. And it is also of negative economic importance, but because often we have to spend money to dispose it off. So spend money how? We have to collect the garbage, we have to take it to a disposal point. So all this, it is not only of no economic importance, but we also have to spend money to take care of it so that it does not pollute our immediate environment. How do we look at waste from the environmental perspective? Now, it is actually a load on the environment and it is a source of pollution. So if it is not handled the way nature handles it, it becomes an environmental load. So when the process of generation exceeds the rate at which it is being consumed or the rate at which it is being recycled or taken care of by nature, it becomes an environmental load, and that is what we call pollution. And if we look at the chemical nature of waste, so it is basically, so we have seen the economic nature of waste, we have seen the environmental nature of waste. Now we are looking at the chemical nature of waste. So what is waste? It is actually a complex natural polymer, and this natural polymer, this complex natural polymer, which is composed of many different things, the different components of it, they have different differing degradation rates in nature. So we will look at some of the names of the natural polymers. So you all have studied about carbohydrate, proteins, fat, vitamins, all that is necessary to take care of our life, to take care of growth that takes place. So waste also has those same elements. It is only that they are non-edible, they are non-usable to us. That is why we are calling it waste. Otherwise, the chemical nature of it is very, very close to that of food. So of the natural polymers, we have starch, amylose, pectin, and this takes about hours to days to degrade in nature by natural processes. Then we have cellulose, hemicellulose. So cellulose is the most abundant natural polymer which is present on Earth. And this takes about days to weeks to degrade. From days to weeks, it takes to degrade. The next thing is lignin. So lignin is very, very difficult to degrade, and it takes months to years. Other things being proteins, fats, they again take hours to days. And in nature, who takes care of this degradation? So there are scavengers who actually consume the waste. They are, so of the scavengers, we have different scavenger birds. We have earthworms, we have centipedes, millipedes. So these all take care of the waste by consuming it, by breaking it down into smaller particles. Finally, there are abundant types of microorganisms which actually degrade any and every natural polymer, and they derive their life-giving energy from the degradation of these natural polymers. And in this degradation process, what is helping the microorganisms are actually biocatalysts or enzymes. So if we go down to the basic level, it is the enzymes which are performing this degradation. And what are we getting in through the process of degradation is humus, is methane, and is carbon dioxide. These are the main products of degradation, the main and the final products of degradation of these natural polymers. So we go back to the previous slide, that so nature is doing all this for us silently without demanding any cost, without telling us whether it is economically important or not. Now, the composting technology that we developed was one in which we decided that it has to be very, very close to natural processes. So what did we do? And how this actually came to us, this problem came to us. So there is a housing society. So just like we have our Anushakti Nagar, there is a smaller housing society very close to Anushakti Nagar in Kurla. And this housing society has 384 bungalows, and each of the bungalow has at least 2 coconut trees. Now, from these coconut trees, as you know, they have huge leaves with a very, very woody stalk or petiole, and heaps of these coconut leaves used to be dumped in their playground. So once an area which was dedicated to be a playground, to be an utility area, that became a dumping ground for heaps and heaps of coconut leaves. And why was it so? Because coconut leaves in nature, they take a very, very long time to degrade. So what one has to do, keep on dumping, and finally to get rid of that, the easiest solution people resort to is lighting a match and leaving it there. So it gets burnt, it further pollutes the environment, but in the process we have got rid or disposed of the waste and reduced it to a smaller volume. So when the people from Kurla Kamgar Nagar came to us with this problem, we thought, how can we tackle it? So we have to do something which is close to nature, which mimics nature. So we again went back to nature and we decided to isolate those same microorganisms. I was talking to you about microorganisms which degrade complex polymers. So we decided to isolate microorganisms from an environment which has this complex natural polymers present. So tree bark, the bark of a tree, this provided us some cues that it could harbor such microorganisms which would be living on this complex polymers. So from the bark of a tree in Anushakti Nagar itself, we isolated several microorganisms which are able to get their use the tree bark as their energy source. And from these several microorganisms we screened, because again what we will use has to be safe for human beings, safe for animals. It should be safe to the environment as well when we are using it at levels more than that is present in nature. So of the many that were isolated, we got one which had all these characteristics, that is safe to handle, easy to grow, and they would grow at ambient temperature. They can grow with very, very little inputs, because ultimately the process has to be economically useful. So we got one fungus which we identified by molecular techniques, and this turned out to be Trichoderma choningiopsis through the molecular identification means. I told you in a previous slide that cellulose is the most abundant natural polymer. So we first tested its ability to be able to degrade cellulose in the laboratory, and we found that in a matter of 15 days it is able to see, this is a cellulose suspension, and in a matter of 12 to 15 days it is able to solubilize it and use it as a source of food. So as far as the most difficult to degrade, of course, is lignin, but the most abundant is cellulose. So as far as being able to handle cellulose, this fungus turned out to be a successful candidate, and hence we made it into a formulation. So what is a formulation? Now, once we have to provide something in an usable form, we have to make it into convert it into a form which can be economically useful, which can be transported, which can be applied with ease, and which has a decent shelf life. So ultimately it has to be sold. So from the manufacturer to the consumer, when it goes, it has to have some kind of a shelf life. It can be stored over a decent period of time. So accordingly, we made it into a formulation. Now this formulation we applied to the waste that was being accumulated at Kurla Kamgar Nagar. So this was the very, very tough to degrade coconut leaves, which was lying accumulated at Kurla Kamgar Nagar. So we told them to cut it into small pieces or shredding. So in nature, this part is taken care of by insects, taken care of by earthworms, by millipedes and centipedes. But here we had to do it manually. So we suggested that you shred it into smaller pieces, Shredding actually increases the surface area by making it into smaller pieces, and thus makes it more available to microorganisms. And then in a fixed proportion, we applied our formulation, that is the formulation of the trichoderma fungus that we made. And in a matter of 55 days, this was converted into a very, very nice black colored earthy smelling compost. And as a result, what happened? So their dumping area where they were dumping waste, they were burning of waste, in a matter of 4-5 months, they could convert it, they could process the entire waste lying dumped there, and they converted it into a nice playground and a park. So inspired by this, they undertook the zero waste project. And in this project, they collect every morsel of biodegradable waste from the houses, and they convert the kitchen waste separately, the dry leaf waste separately, because they have differing degradation rates. And the compost that they get in this project, it is used to beautify the garden that is present in the park, and also they sell the compost at a good rate. So what was a source of actually a fire hazard, a source of snake menace, because under these dumped leaves, a lot of snakes would make their homes. What was actually polluting the environment and also occupying a lot of space was aesthetically very, very, it made the place aesthetically very not likable, I would say. So a simple process converted that dirty place into a nice park and a garden, and people play, people take morning walks over there. So small interventions, this is an example of how small interventions can really change the environment totally. So we undertook another such project in Tata Institute of Fundamental Research for their garden. And there were very, very difficult to degrade leaves like that of Barringtonia. We have the same leaves here also in Anushakti Nagar. Almond leaves, which are very big, then ficus leaves, that is from banyan and from people. So these leaves, we could convert them into compost within a period of about 7 weeks. Now we come to a project very close to Anushakti Nagar in Mandala. So this place has about 50 households or 50 or 100 households. And you see a single worker here takes care of the entire waste of that process, that place. So what she does in the morning, she collects the waste, which is about 50 to 75 kgs. She chops it. She uses our formulation and cocoa pit in fixed proportions, and in these kind of perforated drums. So these drums are also refuse drums, which are taken from chemical companies. So after the chemical is being used, these drums don't find much use. So by making perforations, these drums can be used for processing waste. So every drum has a number. Now, in a matter of 15, so this place is about 15 to 20 drums. In a matter of 15 days, the waste that comes on the first day, on the 15th day, it is emptied. And the first drum then can again be used for a fresh cycle of waste processing. So they use cocoa pit, they use waste, and they use the chopped waste, and they use our formulation. And every day a little bit of rolling is being done to these drums to provide more aeration to the waste. And after 15 days, it is left for sun drying for some time, say about 2 to 3 days, and then they are again stored in drums. So what I want to emphasize is that a single lady takes care of about of waste coming from 50 to 75 households, making it a very, very successful and demonstration of community composting that is taking place. And the waste actually reduces by 90%. So if you have accumulated 50 kgs of waste, you are left with almost, after sun drying, you're left with almost 5 to 7 kgs of compost. And the beauty of this process is that there is no foul odor emanating, very, very little amount of leachate which can be taken care very easily. And this project is actually taking place right beside a temple, and there is no complaint coming that you're processing waste just beside the temple. And no complaint of foul odor or of flies or any other such menace. So now I come to composting of Nirmalya. So this is at Anushakti Nagar itself in Ganpati festival in 2019. So each of the pandals, we provided them with 2 drums, which had our formulation, which had cocoa pit. And every day the floral waste that would come from the offerings would be torn apart and put in these drums with a little bit of mixing. So by the 20th day from the start of the festival, we got very, very good quality compost. And the beauty of this process is that we prevented the entire floral or the Nirmalya waste of Anushakti Nagar from reaching the various water bodies. And you know that when organic matter reaches water bodies, it increases the biological oxygen demand, the chemical oxygen demand, which means to say that the degradation of waste continually uses up oxygen, which is present, the dissolved oxygen in water, thereby polluting the water body. Oxygen is no longer available for fishes and other organisms that survive in the water. So it disturbs the entire ecosystem of the pond, this kind of dumping of Nirmalya. And the entire Nirmalya of Anushakti Nagar, including household Nirmalya. So we had also installed drums near the well area of this is opposite Hastinapur market. And we ensured that all the Nirmalya actually is composted. And you would be surprised that when such processes are followed in temples, the compost that is obtained gets a very premium price, because it is known as holy compost. So it is compost of the compost from the flowers that is offered to the god. So it is another successful demonstration of composting, which can be at temples as well as during festivals. And you know that there is a very big menace of rice straw burning. So we demonstrated that in a matter of less than 90 days, shredded rice straw can be converted into compost by using our formulation. And we further improved this process by adding cow dung to it. And now in a matter of 28 days, we have demonstrated that rice straw, whole rice straw, can be converted into mulch ready compost. So mulch ready means that it can be directly applied to the field, and the field can be plowed. In the process, the compost will get mixed with the soil, and it can be used as a organic carbon amendment. So this is very, very rich in organic carbon, about 28% organic, 28% total carbon it contains. And so rice straw, which was previously being burnt and it was polluting the entire national capital region, Delhi and its surroundings, and even the wind takes the smoke and the smog to even neighboring countries. that can be converted into very, very useful compost, a very useful amendment to the soil, on an input for agriculture in a matter of 28 days through improvement in the process. So this is unshredded rice straw. This is shredded mulch ready rice straw compost, and this is shredded straw. This is rice straw compost from shredded straw. We also studied its effect on plants, so effect of kitchen waste compost and of leaf compost, and as well as its combination. So this is a control plant where no compost is being added. This is just growing on garden soil. And this is a plant growing on, these are actually maize plants from where you get your sweet corn. So this is growing on kitchen waste soil amended with kitchen waste compost. This is soil amended with leaf compost. And this is soil amended with kitchen waste plus leaf compost in equal proportion. And the effect of this compost is not only on one growing season. What we have seen is that even in the next growing season, there is residual effect, and we get very good growth of plants even by a single application of a compost derived in this process. So I would, in short, I would tell you how the formulation is prepared. That is the formulation of the fungus that we had isolated. I had told you that in order to make it available to people, to make it available commercially, we have to convert it into a form with which we can transport it easily, we can apply it easily, and it should have a decent shelf life. That is, from the manufacturer to the consumer, when it reaches, it should remain effective. So all that we need is a laminar flow cabinet, which is present in all microbiology laboratories, and autoclave. So you must have seen an autoclave at a dentist's dispensary or in a hospital. So what happens is the process of sterilization happens, by which all microorganisms which we don't desire, they are removed from the vessels, from the flasks and beakers and all that we will be using to culture our fungus, that is preferentially allowing the microorganism of our choice to grow. We need a refrigerator to store the formulation and a mixer grinder to prepare the formulation. So we prepare it typically in jowar grains, the jowar from which you make nice bhakris at home. So it is soaked, it is autoclaved, and then in the laminar flow chamber that I showed you, it is inoculated, that is the fungus of our choice, Trichoderma choningiopsis, that is added to it. And it takes about 10 to 12 days to grow in these jowar grains, after which the jowar grains are ground in a mixer grinder that we commonly use in the kitchen. And after which the entire thing is mixed with talcum powder to get rid of the excess moisture, as well as air dried, and then it can be packaged into a product. So this is how the fungus grows in jowar grains, in flasks. And this is the formulation that we obtain after grinding. It is slightly greenish in color owing to the color of the spores of the fungus. So you must have seen molds growing on bread, or sometimes molds growing on achar. So this organism is close to that kind of a fungus, but it is not harmful to humans. And how do we do a process of composting using this formulation? So what you do is, first you collect the biomass, or you collect the waste, you chop it into smaller pieces. If it is a dry waste, like dry leaves, which we obtain from a garden, from plantations, like we typically have in Anushakti Nagar, you have to add water to it to make it wet. And if it is already a wet waste, like kitchen waste, like food waste, you have to add cocoa pit or preformed compost to take care of the excess moisture. What happens if there is excess moisture in a composting bin? It gives rise to foul odor. What happens is some anaerobic pockets, that is pockets where oxygen supply is very less, occurs if water stagnation is there, and there bacteria, such bacteria start growing which produce methane, which produce hydrogen sulfide, and hence give a very, very foul odor. So if we don't want this to set in, we have to make the composting process, excess composting process, we have to make it free of excess moisture. So for that, we add either coco pit or preformed compost, and that absorbs excess moisture. After that, we add the formulation in the in proportions which are given in the packet that you will buy, and a regular mixing is required. So if it is dry leaves, about once in 3 to 5 days, the entire composting mixture has to be stirred. And if it is kitchen waste, it has to be mixed every day. And this mixing actually makes oxygen available to the microorganisms. It also helps in maintaining that optimum moisture that I told. So if it is leaves, they will take about 4 to 6 weeks to form compost if dry leaves are used as the starting material, and if kitchen waste is used as the starting material, typically 15 days, in 15 days compost is formed. So after this process, the entire mixture, it can be the compost, the wet compost that is obtained, it is left for sun drying and curing. So in the process of curing, what happens? Now the temperature of the compost comes down to room temperature, and this takes about 3 to 5 days, after which it can be used in the garden. So you can wait for another 15 days, during which microbial activity comes down a lot, and then use it in the garden. So here I have just shown how typically leaf compost is being made. So this is a shredder in which the leaves are cut into small pieces. So a whole coconut leaf will look like this after it is shredded. Then formulation is mixed in water, and this formulation is then applied to the heap of shredded leaves. And within 7 weeks, you can get nice compost out of the dry leaves that were lying idle in your garden. This is the process of kitchen waste composting. So you can see this is being chopped into small pieces. They will be loaded into this drum. Before that, the drum is layered with preformed compost and coco pit. If you don't have access to coco pit, you can use excess of preformed compost, or you can also use compost which is made from dry leaves. But preferably don't add shredded dry leaves, because shredded dry leaves take a long time to degrade, because it is primarily made of so much of cellulose and hemicellulose. Takes long time to degrade. So non-undegraded pieces will be visible if you use only shredded leaves. So if you don't have access to coco pit, use composted dry leaves. So then this kind of a pre-mix is made of waste, the coco pit and preformed compost, and this is loaded into the drum. Formulation is added, mixed well, and a little bit of layering is done with coco pit on top or preformed compost on top. And so this is how it looks, the waste looks after it is being mixed with all the components that I mentioned. So this is its look on the first day, and this is its look on the 15th day. And after 3 weeks, you have the final product, which is nice looking manure, which can be applied in the garden. So here I have given the proportions of various things to be added, which is not very important right now. I would again stress that how beautiful plant growth takes place when we add this compost. And mind you, no inorganic fertilizer has been applied. So this is a very, very welcome replacement to inorganic fertilizers like urea, superphosphate. And since we are not using inorganic components, it is a very good input for organic agriculture, that is inorganic and synthetic material free agriculture. So what is the inspiration? Why should we follow such a process? Just to manage our waste? Certainly not. It is not just a waste management process. It is the output that we are getting from this process. It is a very good input for organic farming. And here I would give you some more information regarding agriculture. So you know that it is the top soil, the first few inches present in the soil, which is actually life-giving, on which entire agriculture of the whole world depends. It is the first few inches of the soil. Now, this part of the soil has to be rich in organic matter. Only then it will support microorganism growth. And it is not just enough that you plant a seed and it will, you sow a seed and that will grow into plants. Microorganisms in the soil play a very, very important role in providing nutrients to the plants. So what they do is that many of the nutrients are stored in the soil in a locked up form. What microorganisms, through their physiological activity, they make these nutrients free from their locked up form and they make it available to the plants. Now you see the beauty of the process. These microorganisms can survive in the soil, that top few inches of the soil, only if organic carbon in the form of humus, in the form of dead decaying leaves, are present in the soil. So that is what it provides the ecological niche or the home for the microorganisms, or the template for the microorganisms to live. So what in an urban setup, the food that the waste that we generated, it should ideally go back to the agriculture soil and in an usable form in the agricultural soil. So actually we are disrupting all natural cycles through our process of consumption, in which, supposing we eat a banana and we throw away the chilka, and the chilka or the peel that goes into the banana dumping yard. That is not the process that should happen. It should be composted and it should go back to the same soil from where our banana plant grew, from where our bananas came. So through this use of inorganic fertilizers, through the indiscriminate use of pesticides, fertilizers, and different other components, through machinery-based agriculture, what we have done is we have made soils, we have taken off all the organic carbon that was present in the soil. So the organic carbon, now Indian agricultural soil has become organic carbon depleted. So what happens after a few years of this indiscriminate use of chemical fertilizers? Plants are not being able to use whatever excess of fertilizers you are adding. They are not being able to use. Why? Because the soil does not contain organic carbon, which will harbor microorganisms, which will make this inorganic fertilizer available to the plant. So our waste management strategy of converting waste into compost and finally adding it back to the soil actually is making organic carbon available to the soil, is making is compensating for the depletion of the organic carbon, and in the process the microorganisms which were lost from the soil will come back, and that is how they will help. It is not only the components of the compost, but also the fact that they will support the growth of useful microorganisms, which will help agriculture. So that is why in a few slides before we saw such luxuriant growth of the maize plants. So by managing waste in a proper way, in a way that was very close to nature, we are generating good inputs for farming. We are making up for the depletion of organic carbon that had taken place. We are saving on a huge amount of money that is being spent on inorganic fertilizers. We are improving the health of the soil. So soil health is something like your health supports all your activities. So a healthy body keeps a healthy mind, is the house of a healthy mind, and it supports all your activity. You would be able to run, you would be able to play, you would be able to dance, sing, do whatever you want to. Similarly, a healthy soil supports healthy growth of crops from which we get our food. So soil health is determined by the amount of organic carbon it has, the amount of water and moisture it is able to hold. So this organic carbon, what it does, it helps to hold water. It also increases the porosity of the soil. So it is very, very important. See, the roots of the plant are living parts. So they also need to breathe. When you add organic fertilizers, they actually increase the porosity of the soil, makes the soil such that air is able to be exchanged with the atmosphere, and thus the roots remain healthy. The roots are able to breathe well. They are able to actually proliferate well and go down deep and collect more and more nutrients for the plant. And that is how the plant also grows luxuriously. Also, a soil which is rich in organic carbon, you see what happens, it is able to hold water. So water does not go off like a runoff during heavy rains, and it also creates good growth of roots, by which again the plant will be able to hold on to soil. So weathering of soil, or losing of the top layer of the soil to erosion, to runoff due to heavy rains, that can also be prevented. So when we follow natural processes, the blessings are countless. It is not only that we are managing waste, we are not allowing the dumping yard to grow, but we are actually making nature, we are actually converting nature in a manner that it is able to sustain our life. So we are allowing nature to sustain our life, and we are actually integrating the entire process of recycling in a natural form. So here, this is an example. So a college which was following the waste processing, the composting process, they have converted a part of their campus into an organic farm where they are growing brinjals, they are growing sweet corn, papaya, and they are composting the entire waste that comes from their campus, and they are getting nice vegetables and fruits. So they are one of the licensees of our technology. And this is the list of companies, housing societies who have taken this technology, and they have also brought these products in the market. These are the names of the products which are available. And in 2017, BMC actually stopped lifting garbage from decent sized housing societies in Mumbai. So our process came to rescue many of these places, and these are the products that are available. So there are startups in organic farming, in waste management, which have taken our product and they are successfully selling it and making business out of it. And this is an example of a company which has converted our product into a home composting kit. So this is available in Amazon by the name BioZap. And these are some of the awards that our licensees have won. So this was a Clean and Green Society Award, which was given to Kurla Kamgar Nagar specifically for converting their society into a zero waste, zero garbage society. And in this process, coconut leaf composting, which was a very, very unique idea, that actually earned them a prize of 5 lakhs from Maharashtra Pollution Control Board. So I had shown you the threats that currently human civilization is facing: global warming, agricultural crisis, and the other crises. Yes, so if we diligently follow natural process of, or close to natural process of waste recycling, we can really take care of global warming, of agricultural crisis, and thus make our planet more livable. So through a simple intervention, this was actually a very, very simple intervention, no rocket science, no great process to be followed, just following what nature does and trying to replicate what nature does. So we have stopped pollution. If we follow this process, we have taken care of environmental pollution. We have prevented landfills from growing more and more. We have taken care of greenhouse gas emission from pollution, from dumping, from senseless dumping. So we have taken care of the environment in so many different ways. And this is the process that we are doing. We have developed a very good agricultural input. And this process also generates employment. So once we have we stop disposing our garbage into these dumping yards, the people from the very, very lower strata of the society, namely rag pickers, so they are the human scavengers of the waste that we dump. They try to get useful material and then sell it in the market. So they are our recyclers. Indeed, they are our recyclers. So once this garbage dumping stops, they lose their source of income. So we can provide these people from this very, very lower strata of the society a very good, hygienic, dignified, respectable source of employment through processing of garbage in a hygienic manner. So their health, their immediate environment is taken care of. They get social security in terms of a stable source of employment by processing garbage in a hygienic manner, as I told you. We have taken care of the environment by the process of carbon sequestration. So we have captured carbon dioxide, which was freely circulating in the atmosphere, and we lock it up in the form of compost or manure in the soil. We take care of the aesthetics of a place, as I showed you. So a dumping ground has been converted into a beautiful park. And see what a beautiful amendment and input for agriculture it is, thereby saving money of the farmers for inorganic, which they would have spent on inorganic fertilizers. It also saves the country of a huge amount of foreign exchange that we spend in procuring several inorganic fertilizers, which the country is not self-reliant to make. So we are saving on so many different factors, and we are getting healthy plants, healthy crops, which we would consume and then follow the natural cycle. So I thank you for the patience of hearing me out for about 40-45 minutes. And so my message to you all is, as far as possible, let's go back to nature in all our activities, not only in processing of waste, but let's put in every day, let's put in a little bit of thought. Like, instead of taking a plastic bag, why not carry a cloth bag with ourselves? Instead of taking our vegetables in a plastic, telling the vegetable vendor that you put it in a plastic, let's carry our own bag. Let's not dispose of our batteries mindlessly along with our wet waste. Let's do segregation at home. And if possible, take up community composting projects. Our Anushakti Nagar is very, very clean, green, and beautiful. Let's do composting at our levels and make it even more beautiful. Let's give back to our farmers the much needed compost that we need. And in this regard, I would tell you that the fertilizers companies, actually, they give various kind of rebates to procure organic fertilizers, and they are supposed to sell some bags of organic fertilizers for all the inorganic fertilizers that they produce. So all these methods and are available. People often ask that what do we do with the organic compost that we have obtained? So government also, in this regard, they have various schemes and processes available. So it is up to us to actually take initiative and make these processes useful for, again, not only for us, but for the next generations to come. So thank you very much. And your questions are really welcome.
Madam, some of the viewers have asked some questions, so I'll just repeat on behalf of them. So one question was that how long it takes to degrade coconut shell and fiber?
Acha, coconut shell and fiber are actually difficult to degrade, and we have not tried doing this by our process. So I won't be able to answer you on that. As far as coconut fiber is concerned, yeah, we are trying a combination of different processes, and very soon I think we will be able to answer that question.
Okay, madam, there was one more question that how can we use the concept of biocomposting at household level? Because the person has mentioned, or rather the student has mentioned, that you have already explained at say society level, or maybe at a big campus, how to manage it. So at household level, what can be done, and how can the concept of biocomposting be used? And second part, what kind of support we can get if we try to do something at household level?
Yeah, so this is a kit that is available in Amazon. So you can buy this kit and follow the instructions and do the process. Alternately, you can actually support, what we suggest is that you support at the community level, where there will be someone to take care of your compost bins. But there are also many solutions available now on the internet. BioZap is one such solution, which is based on the process that we have developed. So you can follow this. Other than that, there is Trustbin. So you will get a host of things in the internet.
Yeah, madam, if you have answered the question, or would you like to tell something more?
Yeah, sure. Go ahead.
I think these were the questions only. I could not get any more questions. So if you would like to give any more message to our students or staff members, or else we'll just end the session as per your convenience. So if you feel you want to give some more message, you can go ahead.
Yeah, so I was telling about our responsibility, everyday responsibility. Yeah, so not wasting food is another important responsibility. So we should approach our food with a lot of gratitude, see the entire chain that has brought the food to our table, to our plate, and giving gratitude to the entire chain. It is our responsibility that we don't waste it. We make optimal use of it, and whatever will be left over, we send it for composting, we send it for all the natural processes of recycling, and finally we also take care that it goes back to the soil. So this is my message to the students. Thank you,
madam. So on behalf of AES, I would like to take this opportunity to thank Dr. Poulomi Mukherjee for explaining the topic biocomposting of garden and domestic waste using BARC technology. The explanation was very nice. We have received a lot of comments that students could come to know a lot of new things today, and they would like to explore these things. I hope this lecture will be really useful for all the audience, especially for the students and the staff members of AES.